Good morning, everybody, and welcome to the American Museum of Cuban Diaspora. My name is Regina Rodriguez, a PhD candidate in environmental engineering at the University of Florida. I have the pleasure of welcoming you to the 2018 Cuban Infrastructure Scholarship Competition. The hosting committee is made up of members from two sponsoring organizations, the Association of Cuban-American Engineers and the Cuban-American Association of Civil Engineers. I would like to remind everyone that this event is being live casted online and accessible using the YouTube link in your program. Buenos días a todos y bienvenido al American Museum de Cuban Diaspora. Mi nombre es Regina Rodríguez y soy una candidata de doctorado en Ingeniería del Medio Ambiente en la Universidad de la Florida. Es un placer hoy darles la bienvenida a la competencia de 2018 para las becas sobre infraestructuras cubanas. El comité anfitrión está compuesto por miembros de las dos organizaciones patrocinadoras, la Organización de Ingenieros Cubanos Americanos y la Asociación de Cubanos Americanos de Ingenieros Civiles. Muchas gracias por estar hoy aquí con nosotros y en el live. Queremos recordarle que la competencia está siendo transmitida en vivo y puede ser accesada usando el link que tienen en su invitación. El resto de la competencia y presentaciones continuarán en inglés. At this time, I would like to recognize the presidents from each organizations and thank them for their support on this program. Roger Puerto, the president of the Association of Cuban-American Engineers, and Yvette Alman, leading the Cuban-American Association of Cuban Engineers. We are very grateful to Bulla Gastrobar, owned by Carlos Antirium, who has graciously sponsored the Cuban Infrastructure Scholarship Competition event with a $20,000 per year for a 5-year sustainable commitment. Many of you may be familiar with the original Bulla restaurant in Coral Gables and now Doral and Winter Park. Prior to beginning our program this morning, I want to welcome Mr. Roger Puerto, the Cuban Infrastructure Committee Chair, to provide us some introductory remarks. Roger has played a key role these past years in the competition as it's grown more and more successful. Thank you, and please welcome Mr. Roger Puerto.
Good morning, and welcome to I'm going to keep it short, to the Cuba Museum. It's a lot easier than to say the American Museum of the Cuban Diaspora. But welcome. This is, as a matter of fact, I welcome also to the competition, which, as Regina said, is sponsored by the Association of Cuban-American Engineers and by the Cuban-American Association of Cuban-American Civil Engineers. So this is, but before I go further, I just can't go before I recognize Regina Rodriguez. A few words about Regina is that she has been my right-hand person for the last 3 years. Without Regina, I would not be able to do what we have done. In addition to that, Regina, in 22 days, is defending her dissertation. So she's going to be the Dr. Regina Rodriguez. Okay. In addition to that, she gave us news the other day, and we had dinner on Thursday, and always concerned about the growth of this program. And, we're going to do things that to really actually give it even more emphasis. But she also told me that she was actually named Chief Operating Officer of the company that she started as a lab assistant as an undergraduate. So the company just went public, had an IPO. At the beginning of the year, so congratulations, well deserved. I couldn't think of anybody else but you, so thank you. And I also want to recognize, sitting in the back is Roxanne Ramos. She's one of our board members in the Association of Cuban-American Engineers. She's also the coordinator of the gala. We have the annual engineering gala on March 17th. 2018 at 7 p.m. at the Hyatt Airport. And we're very, very much interested in getting you guys to buy tickets for the gala. It's not that expensive, $85. So if you want to return to Miami to to attend the engineering gala will be there, and Roxanne can sell the tickets to you. So it's not really that complicated. It's an event that actually brings 500 people together. It's a tremendous networking chance for people that are basically getting into their career. We also will recognize a number of students that have actually won scholarships at the gala this year. So before we go, or let me get into the actual competition. We started in 2008, before I actually joined the organization. It was an idea that actually, how do we get young people to, number one, think about Cuba? And it was the idea at the beginning was, how do we get young Cuban-American students and people to think about Cuba and the future of Cuba? Because the fact is that the infrastructure in Cuba has decayed, is decaying, and will continue to decay. So the folks that actually began the process of organizing this competition had that in mind. And it actually concluded in 2010 with the first competition. So this is the 9th competition of the Cuba Infrastructure Scholarship Competition. So I'm very, very proud of having been working on this for the last 3 or 4 years. And basically the thought was that we want to get, as I said before, we want to get the students to actually think about the future of Cuba and how to improve the infrastructure in Cuba. And the mission is right there. It's very simple. It's basically to promote high-level engineering and high-level science that may apply to the future improvement of Cuba's infrastructure, which is very, very, very decayed. Okay? Let's flip to the next one. The objectives to accomplish this, and I'm moving around, so I apologize for losing my voice here. To accomplish this mission, we will, but again, and that's the reason why we bring engineers here. We foster engineering. And we do have 3 different type of presentations that we have this year. We have presentation that had to do with electricity, or converting the solar power into electricity. We have a transportation presentation in the city of Havana to actually give more people access to public transportation. And also we have environmental, which is how do you treat the residual water? How do you clean that residual water, especially after Hurricane Irma? And that's basically what we have. We want to foster engineering and science education. We want to form specialty committees to conduct research and analysis and collaborating with other organizations and disseminate the findings. This project will actually be housed in our website so that anybody that wants to have access, and the future, what we envision the future is that we'll have a repository of Cuban data, repository of Cuban infrastructure, so that in the future, if organizations want to work and improve Cuba's infrastructure, they'll have a chance to get information from what you have done. And there's another side of this, which is the professional side. We have about 17 different projects that Dr. Manuel Cerejo organized the effort back in 1992 that deals with different infrastructures, different type of infrastructures. And we basically just need to bring it up to date. So we have a lot of information that we'll have in our repository concerning Cuba's infrastructure. So with that in mind, I offer my good luck today. You have done a great job. You have worked very hard. I know what it takes. You don't get extra credit for this. You have to do this in addition to preparing for the final exams. So I know how hard it is to make it happen, and I thank you for being able to be here today. And one more note. You notice that where are the Cuban-American students where are they? They're not as involved anymore as they should be involved, and that's one of the concerns that we have. You guys are not Cuban-American from what I know. So thank you for caring about Cuba's future. And with that in mind, I give it back to Regina. Thank you.
Before we move on to the competition, we have a special guest here today, Professor Julio Cesar Hernandez, who has graciously joined all the way from Notre Dame today, and we're very excited to introduce him as our keynote speaker. Professor Hernandez is the author of a master plan for the 21st century Havana and is currently drafting a master plan for the future of Cuba altogether among numerous professional articles published in various international journals. Julio Cesar Perez is currently an associate professor of the practice of at the University of Notre Dame School of Architecture. He previously taught as a visiting professor during the fall of 2012 and lectured in 2011 with the guest juror in 2011 in this institution. In 2001, he became a Loeb Fellow at Harvard University, where he was selected as a 2012-2013 Wilbur Marvin Visiting Scholar. As an academic, he has lectured and taught in the most prestigious universities of both the United States, Canada, Europe, Costa Rica, Cuba, and Bermuda. He's graduated in 1982 from the School of Architecture at the University of Havana, and he's taught design studio and lecture courses in architecture and urbanism there from 1988 through 2006. He is an accomplished scholar, visionary, and international consultant with proven leadership, communication, and organizational skills concerning strategic planning, consulting, architecture, building history, urbanism, and creating solutions. But without further ado, I would like to welcome Professor Julio Cesar Perez.
Good morning, everybody. Thank you. It is a great pleasure and an honor to be here. Thank you for being here. I would like to start by thanking this prestigious institution, the Association of Engineers, Cuban-American Engineers, and I would like to thank Engineer Victor Pujals, who crafted this invitation. He was telling me this morning that I would be glad to skip the winter up north. And it's good to be back here in Miami, which is, we believe, a part of Cuba. And this is a wonderful initiative. It's wonderful to have the students and this competition. We do believe that infrastructure is the key to the future, not only of Cuba, but also to the United States. I would like to start by saying that we are talking about the future, but for us to know the future, we need to know our past, a past that we are very proud of. Engineering in Cuba was a key point of development from the colonial times. In fact, from the initial times when all the European engineers designed and built these wonderful Renaissance fortresses that became the most impressive defensive system in America. Cuba pioneered. Cuba had the first aqueduct in America completed by the same Italian engineer, Antonelli, by 1592. And throughout history, I'm going to show you, how proud we are and we should be of our identity as Cubans, and how this identity was forged along the 19th century and throughout the whole 20th century. So we believe in the future of Cuba, and this is why I've drafted these plans for both Havana and Cuba. This was, by the way, the first master plan for Havana, drafted by a nephew of Antonelli, Cristobal de Roda. And then this is the first aqueduct in America, as I said, that we should be proud of. And then Havana became the most important colony for Spain, as we know. So everything would be rehearsed there. Everything would happen there before than in any other place. And that would also be a trademark for Cuba along the years and along the centuries. In the 19th century, the first expansion plan was carried out by colonial engineer Antonio Maria de la Torre in Havana, Cuba. The first expansion of the whole America region. And the first prize in the international exhibition in Paris was awarded to Cuban engineer Alvear, Francisco de Alvear, who could not see this project finished because he died before, but he was also the man who conceived of the Malecón, the first idea for the famous Malecón of Havana that was implemented by U.S. engineers Meade and Whitney between 1898 and 1901. That was Alvear's idea. So it was the embryo that U.S. engineers used for developing this idea further. This is a glorious period in Cuba because the U.S. engineers developed, number one, a huge survey of all the infrastructure, as you can see in these plans here, and also works that turned Havana into something that was different from the colonial times. To start with the Malecón and then the paving of the streets with a very progressive system, the macadam system, and then also the first and most innovative sewage system took place in Cuba. And this is one of the what we call the 7 wonders, but I guess there are more than 7 wonders of Cuban engineering. Is the sewage siphon, which was carried out by engineer Samuel Gray. And then in the 1930s, but started in the 1920s, we have the Central Highway, we have the Foxa building, which is also something to be proud of because Cuban engineers and Cuban architects working together proved that they could do an apartment building out of reinforced concrete instead of a steel frame structure. And at that time, they were questioned by both American and Canadian engineers. They said, this is not going to happen, this is not feasible. They proved that it was feasible, and they did it. And this is the Foxa building that is a gem of Cuban engineering. Then also the Havana Bay Tunnel, built in 1958, is also something to be proud of. And then the bridges, the several bridges that were built in Cuba. But we're now here, present Cuba, 21st century, and we should be aware of the challenges and also the opportunities that we have for engineering projects in Cuba, because infrastructure is a key factor for any future development. And so we have acknowledged it in the plans we have conceived and drafted for the city. Number one, transportation. Infrastructure transportation needs an upgrade. And when we refer as an upgrade, we almost say starting from scratch. So there's a lot of work here for any engineering firm, airports, ports, and the whole railway. As you know, Cuba pioneered in railway. In 1837, Cuba became the first country in America to have a railroad after the US and the UK. So that's also something we're proud of, and we're going to see the state of the railway station. So when it comes to airports, we know that the many airports in Cuba are facing great challenges because of the increase of tourism. So the current Havana airport that I'm going to show is in critical conditions because it cannot grow further. So we believe, and according to this, this is included in our master plans, that the next future airport for Cuba is one that has the best runways that was built in the 1940s by U.S. engineers. The company was called La Cayuga, and it was built in San Antonio de los Baños, right in the outskirts of Havana, and connected with the Novia del Mediodía highway that I'm going to show also. So we believe that this is the place where the next future international airport, that we aspire to be not only an international airport, but an international hub, meaning an intermodal terminal. Then we have, this is the several terminals that we have currently in the Jose Marti International Airport in Havana. They lack the appropriate infrastructure in terms of the customs, and this is the Terminal 3, which is the most modern one, the one here. And having flown late last year there, it shows decay and a great need of maintenance, as most things and buildings and bridges in Cuba. So when it comes to ports, Cuba was blessed with many bays, beautiful bag bays, ample, chartered, and then, of course, we have many ports. And probably the most talked about one is the port of Mariel, that was recently revamped, because the port of Havana has this derelict industrial character, which is good. We are getting rid of the industrial character of the harbor, and we have a wonderful opportunity for making a contemporary harbor related to sports in such a way that it becomes, again, the engine of the Cuban economy. As you know, the Havana harbor was always the economic engine of Cuba. You may remember that Havana boasted the most important arsenal in the world in the colonial times, 17th and 18th century. El Arsenal de La Habana, the arsenal of Havana, was the most, not only well known in the world, but the most important one and the most productive. Of course, they terminated the Cuban woods, but that was a time when no one talked about sustainability. So this is the harbor of Havana, this is the bay, and we, of course, have a plan for the bay. We believe that the renovation of the Bay of Havana can become a model for the whole regeneration of Cuba. And this is a scale model, so you can have a sense, for those of you who haven't visited, of the potential of the area. And then there are other ports that are traditionally important, like the port of Matanzas, Santiago de Cuba, Cienfuegos, and some of them that are also located in beautiful bays, like is the case for Matanzas and Cienfuegos specifically, but also Jibara, that was turned down by recent hurricanes. So when it comes to railway, this is the Central Railway Station built in 1912 that is going to become Museum of the Railway in Cuba. And the terminal is going to be relocated, a great opportunity for the railway in Cuba. But this is important because Cuba, as you see, is an elongated island. So railway systems make a lot of sense. It's the most efficient transportation concept that we can use. And as we see, it was developed across the island. So we need to take care of this because the most ancient railway stations are really, really in bad condition. They have lost their roofs, even though they have been recently rebuilt in a very poor way, by the way, like this one I'm showing here. You see, it lost its roof, and it was rebuilt in a very disastrous condition. So this is the existing condition of the tracks, as you can see. Nobody takes care of this. It's a mess. It's dangerous. So this is something that is out of code in all regards. And also, these train stations were built, most of them in the 19th century, so they are mostly a century old. Well, we are also proud to keep the only electric train running in America, the Hershey, related to the chocolate Hershey family, who had beautiful gardens in their batey. I don't know if there's someone related to Hershey here, but chocolate was not only a byproduct of this train, and we believe that this is part of our industrial heritage that should be maintained and kept. So this is also something to bear in mind for the future. Well, what about roads, bridges, and tunnels? Well, this is a map showing you the thoroughfare, and you can see that, yes, there are roads, but as it's been recently acknowledged by the current president of Cuba, they are in bad conditions, and I think he called it a living cemetery, because there's lack of lights, lack of lighting, and appropriate signalization, etc., etc. So it's very dangerous for people who go there and rent a car and go across the island. Is a real danger. It's a threat. So when it comes to Havana, the capital, of course, you see here how well served it is by roads, but you find that they have holes and they are not well lit as well. And then the highways, they're really in bad shape. They have drainage problems, they flood, and you can see that they need also to be taken care of. Well, the tunnel, this is good news. It was renovated. It had a comprehensive renovation some years ago, so it's in good shape. Besides, it was very well built by this French company in 1958. But then some other tunnels, like the one on Linnea Street, on Fifth Avenue, etc., they flood. They also need maintenance and need to have a project that takes care of them. Bridges. Well, in a city like Matanzas, that is also known as the city of bridges or the Athens of Cuba, some of these bridges have received some maintenance, but most of them, they haven't. So they need to take care of these too. This is the Yayabo Bridge over the river of the same name. It's one of the oldest in Cuba. As you know, Santi Spiritus was one of the first settlements founded by the Spaniards, by Diego Velázquez himself. So it's also part of our heritage. Then we have these conditions. These were bridges that were built by American companies working in Cuba. You know, there was a spirit of collaboration along the whole stretch between 1902 and 1958 between Cuban and American engineers and architects, and the most important construction companies, engineering companies, worked in Cuba, and they worked closely with Cuban architects and engineers. So there's a whole history, there's a whole culture about that. But right now what we find is that, you know, this deteriorated condition forbids transit. So some of these bridges have been vandalized, and it's really giving us the idea of a very dangerous condition as well. So these are really pictures that are really frightening, because you think, well, what if I don't know about this? What if I get there and I find these conditions? So all of them need maintenance. And the Malecon, which is a wonderful avenue, which is considered the living room of Havana, is facing flooding problems. So it has become a real problem for the city, and we don't see any solution in the short term. And this is why you're going to see that our proposal tackles that in terms of solving that in a definitive way. Havana Thoroughfare, where there's some streets that are in good shape, For example, Fifth Avenue, which is the most manicured street in Havana, and with this tower, by the way, designed and built by an American architect, George Duncan. And then we see that there are spaces here. This is a space where there was a plaza built, but it has no urban significance, and also the buildings around it, commercial malls, etc., are really, really lacking architectural design, to say the least. And then there are other streets that you may remember, or at least your families, that are very important in the city, and how the city functions, that are really claiming maintenance and condition. That's also the case for the rest of the country. And I would say that Cienfuegos is kind of an exception. Cienfuegos is a very well-kept city, is very well maintained, so this is really an exception. Water infrastructure and garbage are really, really critical in Cuba. So water supply is tremendously important. Havana has real problems with water supply and garbage, and so just so you know, and this is public records, the Japanese government has made a donation for the city of Havana to take care of the garbage, do a recollection of garbage. So this is completely unacceptable. How can a foreign government help us with this? We should take care of this as we take care of our homes. So anyway, you see the condition, you see what's the problem with the sewage, water supply shortage, electricity, waste management, and sadly, garbage collection. So this is a kind of, it's not only the streets, but also the sidewalks, as we were talking this morning. And this turns the city into a completely unacceptable condition for the normal daily life functioning. So the fishing garbage collection, health problems derived from poor and dangerous sanitary conditions, as we know. So this is something that we should tackle immediately. As I said, water supply, and this is why you see so many water reservoirs on the roofs of the buildings, because of the insufficient water supply to houses, etc. As I mentioned, flooding is also an engineering problem. This is completely, look at the level of water just after, these are recent pictures, just after the recent hurricanes that hit Havana. And the rain caused all these problems, but also because of the Malecon that makes like a ball in between the Malecon and the rest of the city. So green infrastructure, to say the least, is something that we aspire to increase. All this has been considered in these plans that we have drafted for Havana and for Cuba, because we believe that planning, infrastructure planning, is key for the future of Cuba, and that even though when we cannot see the future, we can plan for it. So this is the concepts that the master plan of Havana is based upon, and they're kind of illustrated here. I don't have the time to go through all this in detail. I would love to, but this is just a different lecture that I usually give. And then just for you to have an idea of the potential of the places we have planned for the harbor. For the first time in history, the master plan of Havana has not been dictated by any government, and is not related to any military apparatus. In the colonial times, there were always military plans. They were dictated by the army. They were dictated by defensive conditions. Most recently, the plans that Havana has had have been dictated by the government. This is for the first time a plan that I have conceived based upon the needs of Havana and based on the history, the idiosyncrasy, and the geography of the city, thinking of the future development of the city. So as I said, this is based on these concepts. And then this is probably the most interesting and ambitious engineering project. It's an east-west tunnel parallel to the Malecon, taking advantage of the slope of the reef. And it will solve the congestion, it will solve the flooding, and it will create a wonderful promenade along the whole Malecon, and will give Havana a different and future contemporary image. Like we see in Barcelona, it will give Havana also an increase of green infrastructure, because that would allow it to plant a lot of trees. This is the part that is claimed in such a way that all this becomes a beautiful plaza. This is a part of the plan for the sector of Central Havana, which is the most dilapidated district in Havana. This is the existing, the former National Bank of Cuba, where still the vaults are still there in this building, even though it was turned into a hospital in 1972. As we see, the buildings in white are new, and they provide, this also provides squares and a lot of open space, civic space for the people. This is a plan for Miramar that we believe is very important because of the presence of the Armendariz River, which is also another engineering project. And finally, this is a master plan for Cuba, for the future of Cuba, that we are currently working on. And these are the concepts that it is based upon. And we believe that as we speak, the embryo of this transformation is taking over all of us, Cubans and Cuban-Americans, who believe that Cuba has a wonderful future as it had a wonderful past. Thank you very much.
Thank you so much, Professor. Once again, one big round of applause for him. It is very exciting to see all of the work and thought process that is being had from every area of just engineering, logistics, architecture, being thought about to take back to Cuba and to our homelands that I think most of the majority here feel very connected back to Cuba. So we definitely very much appreciate your thoughts and speech today. This makes a very nice segue to the whole point of the competition this morning, whereby college students have taken some of these infrastructure concerns and have put forth their own proposals for how to better the situation in Cuba, looking at a futuristic Cuba that is not based on a strong dictatorship. So once these doors are open, the potential to bring in our own engineers and the engineering design from the U.S. to be able to afford these new developments. At this time, I do want to be able to introduce the students, but a very essential part of this process is our distinguished judges, who I want to introduce this morning, as they have taken their time over the past couple of months and here today to evaluate the students' presentations and to evaluate their presentations here within their written responses too. So we're very fortunate to have this distinguished panel of judges that combines decades of experiences in different infrastructure sectors that the students will be presenting on today. Their exceptionally impressive resumes are obviously summarized within our program, but I want to take some time here to introduce each of the four of them. So on the right-hand side of our stage, we have Mrs. Maria Borrada, and Ms. Maria Borrada is an accomplished civil engineer in the field of transportation, leader and manager with more than 33 years of experience and complex and varied management experiences with both private and public sectors. These experiences include extensive administrative and contract management, infrastructure projects, construction management, planning, design, implementation of transportation system, and transportation engineering. We are very grateful to have her here as one of our panel of judges today, so thank you so much, Maria. Next to Maria, we have Dr. Vladimir Cruz. Dr. Vladimir is an expert in the field of animal production and agriculture. With more than 50 years of experience, Dr. Cruz is the Director of Agropo Systems and Agriculture and Livestock Division of Bon Mas Corporation. He is also an International Development Representative of the Florida Department of Agriculture and Customer Service. So thank you so much, Dr. Vladimir, today. Next to Dr. Vladimir, we have Mr. Rafael Palacios. Mr. Rafael Palacios attended the University of South Florida in Tampa and graduated in March of 1971, the Dean's List Scholar, Bachelor in Science in Mechanical Engineering. His emphasis was specifically on energy conversion and mechanical design. Mr. Palacios' professional career spans a period of 5 decades where he has proven to be a leader in mechanical engineering, construction field, and with a number of significant projects exceeding a total of $1 billion and authoring a number of publications. So thank you so much for your efforts today. And last but not least, we have Mr. Mario Vada. Mr. Mario is a graduate from the University of Miami and the University of Florida. At Miami, he received a Bachelor of Science in Electrical Engineering from the College of Engineering, and he has his Juris Doctor from the School of Law. He brings over 40 years of project experience in generation, transmission, planning, and resource planning and management for major electric utilities from the East Coast to the West Coast. So thank you so much, Mr. Mario, for being here today. Once again, we are very fortunate to have this distinguished panel of judges with us today, lending us their experience in all of their many years of work and guidance to our participants here today. So thank you for being here. So now this is where the exciting part happens, and we are welcoming 3 participating groups, and I will walk you through the process and specifically through the agenda where the teams are going to present. We have 3 teams from various universities. This year we received various submissions from universities across the United States. The selected universities to present here today include the University of Florida, the University of Alabama, and Suffolk University. The judges have reviewed the written proposals that the students submitted over a month ago, and they today will compete for the second part of the competition, where the teams are presenting their projects here today. Each team will make a 20-minute presentation and directly followed by 10 minutes of questions and answers from the judges within the audience as well, and also within our YouTube link and Facebook reading. We'll bring in some of those questions and comments as well. At that time, the online viewers will also be able to interact, as I mentioned, with the teams with their questions as well. The judges will be scoring the presentations based on the following criteria: specifically organization and delivery of the presentation, both verbally and nonverbal image of the presenters, coverage within the time limit of 20 minutes, and proficiency in answering the questions on the back end. Also to be considered will be the quality and creativeness of the presentation materials today. The judges' scores from today will be added to the written portion and of the report score, and the teams with the highest scores will be awarded a $6,000 scholarship for first place, $4,000 for second place, and $2,000 for third place. During the agenda, or during the presentations, we will have a short break right after the first team, where we will have a 10-minute break and we'll have some networking and food outside, and then we will proceed with the last 2 presentations. Lunch will be typically around 12:05, and we will resume back at 1 p.m. for the award ceremony. So at this time, I would now like to begin the student presentations. The first team is from the University of Alabama. Their team name is the Crimson Transit. They will be presenting today on dual mode transit proposing combined utilization of road and rail networks to increase transit accessibility in Cuba. So definitely reliving some of the previous discussions with Dr. Julio Cesar. The team is composed with Elizabeth and Preston. Their faculty advisor from the university is Dr. Stephen Jones, and they were mentored by Eric Sibila as their CISC industry advisor. So without further ado, let's welcome Elizabeth and Preston.
Hi, so first we want to say thank you for bringing us down. We are really excited to be here. I'm Elizabeth Hartzog, and I graduated from the University of Alabama in December with a degree in civil engineering, and I now work for HNTB as a transportation engineer in Raleigh, North Carolina.
Hello, my name is Preston Judy. I'm a current master's student in civil engineering with a concentration in transportation systems engineering at the University of Alabama. And come June, I'll be starting work as a civil engineer in training in transportation planning and traffic operations with Kimley Horn Associates in the Northern Virginia office. Together, we make Crimson Transit. And today, we want to discuss with you our idea for the combined utilization of road and rail networks to increase transit accessibility in the city of Havana. We call this dual mode transit. First, we will discuss a few key background issues that we feel are important to understand our concept. First, we'll talk about transport issues in Havana. Then we'll discuss the general concept of dual mode transportation, also high rail vehicle technology, and then finally, some key assumptions and considerations we took into account for the design of our project. Next, we'll get into the design and analysis phase of our project, where we'll discuss the technical design of our transit corridor using geographic information systems, as well as the service area we projected, including populations of who we might serve with this project. Finally, we'll get into future plans, including the testing and expansion phases of our project and key partnerships we believe can bring this to fruition.
So in order to best describe our reasoning behind picking a dual mode transportation as our subject for the project, we wanted to give you some background information on the current transportation issues in Havana. In May of 2016, Preston and I had the privilege of studying with the University of Alabama at CUHI, the engineering university in Havana, and through our experience in the classroom and in the field with the professors studying air quality, transportation, and the engineering's effects on society and culture, we observed that the existing public transportation options were less than ideal. Buses are the cheapest and most used option among the residents in Havana and are extremely over capacity at all times and consist of inconsistent wait times, causing distress among its passengers. The government's chosen solution to the bus issue was to distribute more taxi certifications to the public in order to relieve the issues. This led to more choices, but the government did not regulate the fares or route, which resulted in drivers favoring the heavily tourist areas and higher route fare options, creating taxi deserts in the areas of Havana that so desperately need the affordable options. You may be asking why there's so much discussion among the different forms of transportation, and this is why, and the reason due to this is because car ownership is less than 0.04 cars per person in Havana. We felt that there needed to be a more creative and innovative approach for this project. Dual mode transportation is best understood as a route design, and why we chose this method was because dual mode transportation systems take one vehicle utilizing two modes of transportation consisting of road or rail, road or air, or road and water. The picture to the right is an existing vehicle in Hokkaido, Japan that is accessible to both land and rail. The benefits of doing this is that it uses existing infrastructure not currently used for transit without reducing the lanes, which after last year's presentation in which I submitted a project on bus rapid transit systems, we realized that was one of the major pitfalls, as it may create more issues than resolve them. And as mentioned, dual mode transportation needs adapted vehicles capable of operation on road and rail. High rail vehicle technology makes this happen by converting road vehicles to rail vehicles. And while in use, the rolling stock is tucked away out of sight, but when needed can be easily employed. Harsco Rail, one of the major manufacturers of high rail vehicle technology, was contacted to get estimates on what the price may be to convert these vehicles to a high rail vehicle. And no response was given. However, we found limited data online, and that said prices would be around less than $10,000 for a 5-passenger vehicle such as an F-150 to the right, and for a medium duty truck, as shown in the lower right, would be around $40,000 to $50,000, and a heavy duty truck, which would be a Freightliner, would be around $100,000 to $300,000. And to calculate the potential ridership, we use the projected numbers from last year's Bus Rapid Transit submittal to serve as a benchmark for our dual mode transit project.
We want to note that we did consider a few different important assumptions and considerations in our project. The major assumption, I would say, is the fact that this general concept is feasible using existing infrastructure, particularly the railroad network in Cuba. We do understand and have some concerns related to that rail infrastructure that we will address later in our presentation, as you might have yourself. But in order to continue forth with the route design itself, we had to assume that this is feasible in general. Next, we had to decide what's considered walkable. Different literature, as well as some experience I have with transportation, suggests that the upper threshold of what someone is willing to walk to some form of transit is around 1,600 meters or a mile. So we chose that threshold to move forward with our route design. And finally, we decided that the average population density would need to be representative of a municipality. We understand that from city block to city block, this might not be perfectly accurate. It could overestimate in some areas while underestimating in other areas, but we felt it was appropriate to move forward with a more detailed analysis of our service area population.
Before Preston gets into the route and design methods, we felt you may be wondering why we chose the Independence Corridor as our option. We had 3 criteria that we designated that would be of extreme importance to this project, and that was 1, it would be close to Cuba, 2, it would reach the downtown core, and 3, it would be a major arterial road running next to an existing railway system.
Now, as you can see, and as I will discuss, Avenida de la Independencia fits the bill in all 3 of those categories. Now, we took a more qualitative approach in how we chose the corridor, but we knew we wanted to take a more technical geospatial approach using geographic information systems for the actual route design of the project. You can see here our corridor fits the bill. The blue line represents Avenida de la Independencia. It's a 6-lane major urban arterial roadway, 3 lanes in each direction, northbound and southbound, for the majority of its 8-kilometer expanse. And in red, you can see a nearly parallel railway almost along the entire corridor, both being approximately 8 kilometers or 5 miles. Additionally, there are various railroad crossings in between, which we will discuss how they will function within our system, that are an important key aspect of going between the 2 different modes of transportation. Now, beginning with our design process, how we went about that was using satellite imagery as a reference. Data is notoriously hard to get, especially in great detail with good spatial resolution in Cuba. Due to the satellite imagery available. So we zoomed in as clearly as we could and as closely, went through and visually inspected, and starting towards the south near Cuhai, went through and built our line shapefiles segment by segment, inspecting each satellite imagery, pieces of the satellite imagery to make sure it was accurate as possible. Because of the nature of satellite imagery, it's actually a mosaic of various images captured from different dates, so we felt most comfortable going through and visually inspecting this corridor to ensure its accuracy. We did so for both the roadway and the railway, as well as the various railroad intersections, and visually confirmed that. As you move in closer, you begin to see some of the issues related to the spatial resolution. The closer you get in, the harder it is to see some of those certain details. Under this red line that represents our railroad, there could be 1 track, 2 tracks, 3 tracks. There could be various informal crossings. There could be things that we are unable to detect. We knew we wanted more detail in order to confirm our rail networks that we were building in our road networks. So using open source data through OpenStreetMaps, we actually were able to import an additional road network represented in the geospatial network, as well as a rail network for the greater Havana region. Doing so, and crossing these 2 modes of transportation, we were actually able to find an additional 6 railroad crossings in addition to the 15 we found through visual inspection, creating a total of 21 railroad intersections with our road network on our 8-kilometer corridor. And this is our northern terminus of the portion, getting into that urban downtown core that we mentioned as one of our 3 categories, just south of the Jose Marti Memorial near the urban core. Here's our southern terminus, just east of Cuba, the National Technical University. And this is where I want to draw attention to our railroad crossings. These are what we refer to as multimodal transfer stations. This is where our vehicles can go between our 2 modes of network, between the blue line, which represents Avenida de la Independencia, the road network, and the red line, which is our rail network, to combine that. This is where the high-rail vehicle technology can be employed, and the vehicles can go from rail to road or from road to rail, depending on the conditions of traffic. We do want to note that while there are 21 railroad crossings, and these are transfer stations, they are not stations in the sense that every single one of them would be stopped. It's stopped at when on the ride. We are intending for this to perform much more similar to personal rapid transit, where, for instance, 5 or 6 students, depending on the vehicle size, if it were for example, the chassis of an F-150 truck or a small SUV, could get into a small personal vehicle with similar or same destinations along the corridor and can stop at a few shared destinations, skipping most of the stops along the way. Because we want to maintain small vehicle sizes, we believe that we can actually go around and use the network much more fluidly rather than putting a large-scale train on there and dealing with some of the issues related to that. We felt that would help us avoid some of the pitfalls of bus rapid transit and light rail, where you are stopping at every single route and not actually getting to where you want to go fast. Next, we went back to what we thought was important for this project. We wanted to see, can we actually potentially reduce traffic congestion along Avenida de la Independencia? After all, it is a major urban arterial roadway. And additionally, can we increase transit accessibility, and for who? So, we don't have a lot of examples of dual mode transit. There's a very small system in Hokkaido, Japan, as Liz mentioned earlier, but we don't have a lot of data or information to go off of to compare this of who we can serve, where can we get ridership projections, and how can we go about that process. So we decided to figure out who we serve and who can access this transit system without deteriorating the current roadway system. And so we decided that meant who can walk to it. So using ArcGIS's network analyst tool, we input the 21 different multimodal stations, or the railroad crossings, as our facilities, and then using that tool, we were able to generate out, along the road network, the walking distances that someone could access our system. In green, you can see all of the areas within 800 meters walking distance along the road network, and then in yellow, it extends it out to 1,600 meters. Now, according to our calculations, this gives us a total service area, meaning walking distance within our transit corridor, of approximately 21 kilometers. Going on from that, we wanted to know who can we actually serve in this area. We didn't want to just take 21 kilometers, compare that to Greater Havana, and assume that was a proportional representation of the population. We wanted more detail. So we went to the National Statistics Office from Cuba, took the total square area of each of the municipalities that our service area intersects, took the total population of each of those municipalities, the information is from the 2010 census, and calculated the average population density of each municipality. We then, comparing it to its representation in our service area, found each service area population for a total service area population of approximately 144,000 people. So that's to say, 144,000 people, we believe, according to our calculations, could access this dual mode transit corridor by simply walking. Now, as Liz referenced earlier, we used her bus rapid transit project as a benchmark of what we could achieve for daily ridership in the past if we want to achieve maybe similar numbers to other examples of transportation in other places in South America as well as North America. If we were able to achieve Miami's level of 2% daily riders, we could get just shy of 3,000 daily riders in this corridor. Bogota, almost 30,000 riders. And if we were able to match Curitiba's numbers of over 60%, this corridor alone could have over 90,000 daily riders.
And now that we've discussed the background and route design, we felt like it was very important to discuss the next steps in the process and how to make these plans a reality. First and foremost, it would be necessary to establish a joint institute between QHI and the University of Alabama, as we have strong existing relations. It would be through this that would pave the way for dual mode transportation. Sorry, go ahead.
And through this institute, it's where the research and testing phase would really begin, where a lot of the work for this will begin. If you remember back to the assumptions and considerations portion of of the project, I mentioned this is where our key assumption was that this is feasible on the existing railroad network in Cuba. There are infrastructural and maintenance issues on the railroad network, as was pointed out in a previous presentation, and we do take this into account. We think it's vital that we were able to use geographic information systems, so in our research and testing phase, we can begin to collect this information by segment, railroad crossing by railroad crossing, and create a centralized database in our actual file that we've created for this project and continue to take that forward throughout the design process. In the information that we looked through, we believe a low capital cost upgrade to a railroad crossing, for instance, with basic pedestrian signaling and pavement markings could be as low as $30,000, or for a complete reworking with complete automatic detection, including automated gates, could be between $250,000 to $300,000 per railroad crossing, depending on the Department of Transportation information you get your data from. From this picture, you can see our service area is just a small sliver of the Greater Havana region and just a small part of the railroad network in the Greater Havana area. We believe by working forward with this testing phase, we can then open our corridor up to the Havana residents, and beyond that, continue this research and testing phase using our system, expand it to the rest of the Greater Havana region, and then eventually to other major cities in Cuba.
And this is a list of every potential partnership that we thought of that could help in making these plans a reality. We want to emphasize, though, that we believe that working with the existing relationships we have within academic institutions is the best way to go in order to make these plans.
Today we've discussed with you our idea for taking the combined utilization of road and rail networks to increase transit accessibility in the city of Havana, Cuba, through our idea of dual mode transit. We think it's very important that a new, innovative approach is taken to solve some of these issues. More buses, more taxis, more cars mean more of the same problems. We think that dual mode transit can increase transit accessibility and can increase mobility for the residents of Havana and beyond, and we do not think there's any reason that Cuba cannot or should not be at the forefront of transportation innovation, and we hope that dual mode transit and Crimson Transit can be a key partner in that process. Thank you, and we'll now take any questions.
Thank you so much, Preston and Elizabeth. At this time, we'll take questions from the judges, and then after the judges go through their questions, we'll open it up to the room. And if you have a question, please come up to the microphone so that everybody can hear you. So we can start with Maria at the corner.
To congratulate you on a job very well done, and for the fact that you're here today, so thank you on behalf of all of us. The question goes to the amount of money that, I wonder if you have a total amount of money for how much this project would cost. I know that you went through the intersections, mentioning on your presentation today that it would be about $250,000 per railroad crossing according to the Department of Transportation. Is that the Florida Department of Transportation because of the proximity, or which Department of Transportation are you referring to?
The lower capital cost number we did get from the Florida Department of Transportation for just a very simple upgrade to a railroad crossing with basic signaling and pavement markings. The $250,000 to $300,000 number, I believe, came from the Indiana Department of Transportation and perhaps the Minnesota Department of Transportation for a full-scale automatic detection, automatic gates. Because of the lack of availability of data, and quite frankly, there's not a large centralized database of the status of all of the different parts of the railroad network in Cuba, we felt more comfortable giving some of the information regarding what's going to go into the process, but we didn't want to give some sort of generalized number without the correct information behind it. That would be the core part of our research and testing phase with that institute with Cuba and the University of Alabama, where we would actually go through, begin logging the statuses, and then we can go through and begin calculating the actual cost. We don't know the economic factor that goes into the relationships that we have to build and what it's actually going to cost when we get there and try to implement this. So we could just sort of start as a basis of what we know it might cost in the United States. Does that help?
Yes, it does. The next and last question from me is, what are you planning to do for additional safety issues related to this multimodal? And I read on the report that you are assuming that people would take on and off these vehicles at any given location along the corridor. And I wonder if you had looked into other safety issues related to that.
We had, but we had figured that a lot of this would go into research and it would be dependable upon how each existing intersection was. And I know that one of the main things that we knew that needed to be taken into consideration was the design and the training of the people who are converting these vehicles and who would be constructing them and working on them in Cuba, because it kind of needs to start at the actual vehicle and rail itself. So we would just have to research that and get the numbers from there based upon what we found as the existing conditions.
Thank you.
I would like also to congratulate you, and I'm going to be very brief in my question, only one question. When you talk about feasibility in your project, you just say feasibility. But feasibility, according to many projects, are feasibility of doing, of actually production feasibility, then economic feasibility and financial feasibility. Where are those other two parts that I don't see, in the project?
I would say we wanted to focus on the proof of concept. This is a very novel idea and doesn't have a true expansive real-world application. We think if someone came up here perhaps 10, 20 years ago and got through that entire process of feasibility with autonomous vehicles and said, this is exactly how it's going to happen, that wouldn't be accurate, and because there's not a full body of research yet there available. We wanted to start this process where we can prove that this is a viable option, begin the research and testing phase, and establish these relationships so we can get that information and actually have it be accurate and from in-field experience and testing with our partnership in Cuba. Our focus on the feasibility was from a maintenance and infrastructure perspective. Is the railroad capable of supporting these vehicles? That was our focus.
Remember that it says economic analysis.
Yes, sir.
I don't see economic analysis.
Again, I want to congratulate you on the presentation. I had basically two questions. Following up on the economics, did you do a cost comparison between doing this and just adding buses in Cuba? Because the problem with the public transportation in Cuba is not that the streets are overcrowded and you can't fit. The problem is they don't have any buses. So did you do any cost comparison between just adding buses and doing this dual mode?
We didn't, but we felt that adding buses would just add to the existing congestion on the roads, and essentially you would either be waiting on the bus in traffic or waiting at the stop for another bus to come.
Then the other question, okay, go ahead.
Well, and I do want to emphasize that we did not look into buses. We really do feel like we wanted to take a new, innovative approach. We could do a bus design and do a bus transit system like many cities have across the world that function much better than Havana and in other places. We want to take a new idea and get away from sort of the traditional transportation planning aspects and propose a new system to complement some of these transportation systems.
The other question is, how do you handle north-south traffic? Because you only got one rail. So you can't have everybody going south at the same time or everybody going north at the same time. How do you do?
So we have one rail line represented on there in the geographic information system, but when you actually zoom in closer, there are portions of the track where there are multiple tracks, there are multiple different sizes, but because they are high rail vehicles, they can get off the tracks in different portions. So maybe for a small portion, if there were single tracking, which in more detail in our geographic information system, we can actually build and tell where those portions are, where they might have to more often actually utilize the road network for certain parts of the rail, and then get up to those corridors where there are multiple tracks, get on transfer stations there, and get back on the tracks. It's sort of a more fluid system where it can flex between the road network and the rail network is the point. So it's not just a traditional personal rapid transit rail only, or just a vehicle only on the road network. They can transfer at different points.
Thank you.
Again, congratulations, as most of the other judges have mentioned. I guess I have three basic questions, and one of your answers may have covered it already, but you mentioned before that your prior project that you had the expansion of the BRT system, if you will, created more problems than it would solve. Could you comment on that a little bit and tell me why you decided to go with this solution as opposed to whatever the other issues were with the other ones? I'm not familiar with it.
Yes, last year we had projected a bus rapid transit system, and we would convert existing lanes to be the stations. And after we went back through and looked at it, we realized that it would probably create more issues because it would be taking away from lanes. And with the projected ridership, it would probably cause more congestion on the roads due to the taking over of the lanes.
Okay, thank you. With respect to the current railroad track that is currently there, is it currently being utilized by rail traffic? And if so, how do you coordinate the movement of the high rail in and out with the train traffic that might go through the rail system?
We don't have existing timetables of the freight or if there's any level of passenger traffic there. There are existing stations where it stops at the northern terminus is some sort of supposedly a passenger station. We don't know how much it's in use, but we do know how the high rail vehicles, the maintenance trucks in America, function when they operate here. They have a series of radio control. It's actually not using autonomy or anything related to cell phone signals. They're using some sort of radio signal where they're back and forth between a centralized headquarters that gives them more or less timetables of here's your window that you have to operate on the corridor. And so we want to function similar to that, like the maintenance trucks in America do function, where there are these windows where we can use our dual mode transit, and when it's not available, it can flex to the road network to not be using it when it's necessary for freight, other passenger projects, and things like that.
Okay. Go ahead, I'm sorry.
Oh, and this would also be addressed during the upgrades of the intersections. Depending on the funding for the particular intersection, there could be sensors installed or other forms of technology to alert so everyone knows which type of vehicle is coming.
Okay, one final question, since you mentioned before that one of the issues in Cuba is the existing bus system has reliability issues, and what you're introducing here in high rail transportation is a more complex system, if you will, in terms of having tires and the high rail portion of it. What are your expectations regarding reliability of this system vis-a-vis a bus system?
We don't know the specific technical aspects in great detail of all of the technology that goes into it. That would be why we feel like it's very important. One of the partnerships we mentioned would be the mechanical engineering faculty at QHI, as well as there are a couple institutes within the Alabama Transportation Center where they could get into maybe perhaps vehicle reliability, more so that we know more perhaps about the more system approach to it. From what I know of the actual technology of high rail vehicle, there's a very simple form of it where there's no electronic or hydraulic components where it's actually implemented, so there's no chance to have some sort of shortage or anything related to that. We would probably start with the very base level of that and move forward from there, but it would require the testing phase of finding out perhaps in small corridors near QHI before we expand it on to see where are those issues and what are we having issues in the system, what's taking too long, what isn't reliable, and move forward from there.
Thank you.
Thank you, judges. Any questions from within the audience here today? Please use the microphone.
Hello. My question is pretty much about safety and actually logistics of operating the system. You're talking about over 20,000 people using the system and about 5 people per vehicle average. How would you control these vehicles entering and exiting the stations in a safety way, and also the ridership as you go along seems to be quite big for the load that rail can take.
So is your question safety issues related to passengers getting in and out of the system, essentially?
More the vehicles getting into the rail and actually getting out of the rail and riding on the rail.
So we imagine that the railroad crossings would be those transfer stations where they're able to convert and essentially transfer between the road and rail aspect. I believe back on the picture with the Hokkaido DMV vehicle there, the dual mode vehicle, it was less than a minute time that it actually takes to transition between. That specific vehicle technology essentially just drives through something that lifts and changes it. We don't know exactly the difference in times for the more adaptive vehicle times, but they would have to have enough time either between the gate or just off the road to have a separate station, a separate like entrance right there, and then drop the technology and then go in. We don't know the exact timing that would take. We just have the example from the dual mode vehicle in Japan, which I know was a very short time for that system.
Okay, and the second part was actually about your riding along the path. How do you control your vehicle stopping or slowing down and then accelerating on that on the rail? Seems to be a logistic problem there.
The controls are actually from the vehicle itself. So the rolling stock goes down and makes it adaptable to drive on the rails. But for instance, the maintenance trucks in America, when they're operating on there, it's powered by the truck, and they're the ones that are, the way that it's integrated with the braking and accelerating system, it's actually self-controlled.
Thank you, Rafael. Any other questions? Bert?
Good morning. Similar to what the what the judges said, congratulations. You put a lot of thought into this and did a great job. So, thank you. My question is more related to the cultural aspects of it. In Japan, you have a very, first of all, what they've done in Japan is mostly a tourist kind of dual mode vehicle, right, that runs along the bay. And so it's meant for tourists to kind of have a scenic view, and then you take them on off the road. Knowing a little bit about the Japanese, how structured they are, how disciplined they are, I worry about the cultural aspects of implementing such a system to people who've kind of not perhaps been aware of technology and structured approach to traffic, et cetera, and not just Cubans, but Latins in general. So my thought is, did you think about the cultural aspects of implementing a system, the discipline that it would take in the individuals, and was that a consideration in why you selected this approach? And if so, how did you think of that?
Well, we figured this would be addressed in the early testing stages once we began running trials in Havana regarding this matter. And also, I know it was similar assumptions were made when Uber was first introduced to the United States, where people were hesitant to ride in other cars with people they didn't know in just a different taxi service. So in the early stages, there could be discounts such as Uber did, or incentives or free rides to introduce the public, a slow introduction to how it is a feasible option and a different option, but it still gets them from point A to point B in a quicker amount of time.
And I do actually want to emphasize, I think certain aspects of the Cuban culture actually perhaps lend itself to this more innovative approach. I think because of the nature of what's happened with transportation in Cuba, cars that should not be functioning anymore have been given life well beyond what they're meant to and well beyond their intended purpose. I think certain parts of the Cuban culture are perhaps way more adept at adapting to some sort of alternative use for a vehicle that really perhaps on paper you might not imagine that was its initial function, and taking it beyond that and imagining a different usage of that. So yes, there are aspects of culture that can be barriers, but if you think about it in a different light, I think that can actually make it perhaps much more acceptable and much more exciting, and actually using that to your advantage rather than scrapping an idea from the start because perhaps culture might be difficult. I think it's an opportunity, actually.
Thank you.
Thank you, Bert. I want to go ahead. Thank you. I want to go ahead and thank the team from the University of Alabama, Crimson Transit. And at this time, we're going to go ahead and take a 15-minute break and meet us back here at 10:45. And we'll start with the next team right thereafter. So thank you so much. All right, welcome back from our short break. We will now be continuing the 2018 Cuba Infrastructure Scholarship Competition. Right before the break, we had the University of Alabama present on dual mode transit. Up next, we will have the University of Florida, Team Chomp Wastewater. They will be presenting on the design of microalgae-based wastewater treatment plant for the Havana, Cuba, for use in Havana, Cuba. We are excited to have the students from the University of Florida join us today, Juan Jane, Mayu Mizutani, and Chang Peng, who may not be here today. Their faculty advisor is Dr. Ben Koopman, and their industry advisor is Eric Antman. So please welcome this team of two young ladies up to the stage.
And thank you, Regina, for the introduction. My name is Juan Jane. My major is environmental engineering. I'm current a PhD student.
Hi, thank you so much for having us today. My name is Mayu Mizutani. I'm a third-year undergraduate student at the University of Florida studying environmental engineering sciences. To begin, we will be introducing our topic with some background information and some context for the purposes of our presentation, and then moving on to our method of designing the wastewater treatment plant, our feasibility, including land use and population statistics, and a cost and benefit analysis. To begin, I'll be describing briefly about the characteristics of wastewater. Typically, there's BOD, or biochemical oxygen demand, and COD, which is chemical oxygen demand, which typically describes the or oxygen depleting species in the wastewater. And this is especially important because with too much BOD or COD in the wastewater, it will make the receiving waters, such as the surface waters in Cuba, to be anaerobic, which will suffocate organisms and flora in the wastewater, the receiving waters. So we will be treating this wastewater to remove the pollutants from the wastewater, to promote public health, to preserve aquatic life and wildlife habitat, and to promote recreation and quality of life in Havana, Cuba. There are some conventional steps to treating this wastewater. Typically, we start with preliminary treatment, which usually includes grit chambers or a large filter to remove the large floating debris. This typically removes 100% of large debris. Then we move on to primary treatment, which removes 60% of solids and 35% of BOD. And usually this consists of a mechanical process, including sedimentation tanks and separation by flotation. And secondary treatment removes 85% of BOD, and this is usually consists of biological treatment, such as activated sludge processes. And then finally, we would do tertiary treatment, which includes chlorination and filtration by use of biochar, activated carbon, sand, and anthracite, which removes 95% of the remaining BOD and solids, as well as nitrogen and phosphorus. For the purposes of our presentation, we will be focusing on primary and secondary treatment. So in Cuba, the wastewater treatment crisis is occurring in much of the surface water, and the surface water accounts for 65% of the Cuba's available water supply, and there are 8 priority watersheds, which serves 40% of the population. As you can see here, there are existing wastewater treatment plants in the lower Almendares River, which is the Maria del Carmen wastewater treatment plant, and then above the Havana Harbor, which is the lower Luyano and upper Luyano wastewater treatment sites. However, unfortunately, these are not operating up to capacity, which means that a lot of the wastewater discharge from industry, agriculture, and municipal wastewater is discharging directly into the surface waters. And you may know that the Almendares is hydraulically linked to the Vento Aquifer, which is a lot of the drinking water supplies in Cuba. Havana. So currently, the demand for wastewater treatment is to serve 2.2 million people in the entire country of Cuba, and the overall demand is 0.6 million cubic meters per day, or 0.27 cubic meters per person per day. However, the capacity is that only 2 large plants are operating in the entirety of Cuba, and they're only at 30% capacity, which means that even if all of the capacity of wastewater treatment plants were in operation, they would only serve about 15% of existing wastewater effluents. So clearly the current wastewater infrastructure is not sufficient to meet the demands of Cuba, especially Havana City. So we plan to solve this wastewater issue using a microalgae-based wastewater plant. This microalgae-based wastewater plant utilizes microalgae, which is microscopic photosynthetic algae, which characteristically has a rapid growth rate, as well as the highest biomass production per surface area than any other organism. And because they produce biomass using photosynthesis, they can incorporate important nutrients such as inorganic phosphorus and nitrogen into their biomass to reduce the amount of nutrients in the effluent of the wastewater, which would cause eutrophication in the receiving waters. And because they can incorporate inorganic nitrogen, phosphorus, and even heavy metals, this can be used to treat industrial, agricultural, and municipal wastewaters. And we chose microalgae-based wastewater treatment plant because we believe that the conventional wastewater treatment plant was not sufficient to meet the needs of Havana. Conventional wastewater treatment, including activated sludge processes, requires a significant amount of chemical additives and energy to aerate the wastewater. While microalgae-based wastewater utilizes solar energy as a main driving force for the mechanisms in the wastewater treatment. So the input of solar energy reduces the need for mechanical energy or chemical energy. And conventional wastewater treatment creates a secondary sludge which is hard to manage and dispose of, while microalgae-based wastewater treatment creates biomass which can be used to create biofuel or biogas to either sell it to the public or to feed directly back into the wastewater treatment plant. It was successful in the past, not specifically for microalgae, but a biomass-based wastewater treatment plant was successful in Cuba at a pilot plant utilizing hyacinth, which is a water plant. And it incorporated BOD, TKN, which is total nitrogen, total phosphorus, and total suspended solids into their biomass, reducing eutrophication in receiving waters. And there are successful examples of integrated microalgae ponds and high-rate algal ponds in New Zealand and rural California. So our goal is to design a microalgae-based wastewater treatment plant for a total of 10,500 people to produce 2,835 meter cubed of wastewater per day, utilizing its low-cost, high-efficient, and low-energy need wastewater treatment plant. And this is modified from our original proposal, just scaled down by a factor, just for ease of presentation.
So here is our overall design of the wastewater treatment plant. It may contain 4 processes. The first one is a preliminary treatment, and Mario just talked about the preliminary treatment process. We will use the filters to remove the large solids. And the second one is primary treatment. We will use the covered anaerobic plant to digest the pollutants in the wastewater using the anaerobic digestion. And the third one, we will use the high-rate algal plant as a secondary treatment process to further digest the organics and inorganics in the wastewater. And the final is we will use the algal harvest method to collect the biomass and resupply to the covered anaerobic plant. So the first one is a preliminary treatment. We will use the bar space at 20 to 60 millimeters at a flow rate range of 0.2 to 0.4 meter per second to remove the large solids. And the remove efficiency of large solids can reach to 100%. And the next one is primary treatment process. We will use a covered anaerobic plant. We call it CAP. And the objective is to remove the most organics and inorganics in the wastewater. And this principle is to use the microalgae to digest the pollutants and under the anaerobic digestion process. And the energy output is the methane, so the methane can further be used to generate the electricity. So it is very energy efficient. And the efficiency to remove the pollutants is high. It's about 60 to 90% of BOD and 50 to 7% of the total suspended solids, and even the 60% for the oil and grease. Here is a diagram of our design. Because we want to extract the biogas from the CAP plant, so we will cover the CAP using a specific material. And we want to meet the capacity of 2,800 cubic wastewater. So we plan to build 2 CAP plants. And then the CAP plant will require 20 days retention time. So based on our calculation, the plant volume of each should be about 28,000 cubic. And the guideline of the CAP construction require that the plant depth should be less than 6 meters. So we use 6 meters for the plant depth. And the freeboard height, it is here, the freeboard height should be less than 0.6 meters, and we use 0.5 meters for the freeboard height. And based on these parameters, we calculate the land use of the CAP plant is about 6,000 square meters. And here is the secondary treatment process. We will use a high-rate algal plant. This plant is open plant, so it uses solar energy to convert the biomass, to convert the pollutants to biomass. And to meet the capacity of 2,800 cubic wastewater capacity, we calculate the size of the HRAP, and it requires about 12 acres. And
so at this point in the wastewater treatment process, there is a lot of total suspended solids, including the microalgae biomass in the wastewater. So after the high-rate algal pond, the wastewater would flow into the microalgae harvest and clarification settler, which is a lamella plate separation clarifier. Because microalgae has a small size and small mass, the settling velocity by graveling low is very, very slow. Therefore, it is very inefficient and difficult to collect the microalgae and clarify the wastewater effluent just by gravity alone. In addition, separation by flotation is expensive because of the increased need for aeration, and we utilize the microalgae method to get away with the flotation completely. And coagulants such as alum and ferric chloride disrupt anaerobic digestion by creating a film around the agglomerate of microalgae, so that was not an option for us. So we looked at a case study in New Zealand that utilized lamella plate separation. So the water would come in through this inlet, and it has suspended algae and total suspended solids within. And it would flow in, and then the flow rate would temporarily stop, and then have gravity settle the suspended algae and solids down and slide down these lamella plates, and then this sludge will accumulate at the bottom, which will be pumped back into the covered anaerobic pond for anaerobic digestion. And then the clarified effluent would be flowed out through this outlet here. And this method would increase the settling velocity by a factor of 490 times. So we would have 2 clarifiers for this presentation, and then the number of inclined plates per clarifier is 7, and at an angle of 50 degrees to reduce clogging, and then also reduce the need for backwash, which requires a lot of energy as well. And then the total suspended solid removal efficiency is 90%.
So make sure the waste plant work the best. We need to check the conditions of the wastewater treatment plant because the algae, they require specific environment to grow, and the main factors to affect the microalgae growth, including the light and temperature. And because high rate algal pond, it is open pond, so the light and temperature will depend on the ambient conditions. And we look into the climate conditions in Havana City. It is pretty good. The average temperature ranges from 21 degrees C to 27 degrees C. And even though in summertime it has rainy days, but the sunshine hours still can reach to about 10 or 11 hours. So it is feasible to build a microalgae-based wastewater treatment plant in Havana. And also, the land use of our treatment plant is not large, and we look into the topography in Havana City. The elevation level is not high in Havana, so it is also feasible in terms of the land use. And we also calculate the cost and benefit. The total investment cost, including the construction and also the materials, will be about 2 million and 1 million, and the yearly operation and maintenance will be around 10,000. And we also calculate the benefit. Including the heat revenue and also the utility revenue from the local residents, and also the fertilizers that coming from the biomass generated from this treatment plant. And the total revenue could reach to 0.6 million per year.
To conclude, our proposed microalgae wastewater treatment plan is to treat 2,825 cubic meters per day with a population of 10,500 people. Our annual benefit is $672,000, and we believe that Havana has a sufficient topography, land use, and existing infrastructure to provide an efficient solution to untreated municipal, industrial, and agricultural wastewater treatment, or wastewater, in Havana, Cuba. Okay.
We want to thank our advisors, Rachel Liu, Dr. Ben Koopman, and Eric Antman, and we also want to thank Dr. Yu Hu for providing a lot of suggestions on our project. And thank you. Any questions?
Thank you so much. At this time, we'll open it up for questions from the judges.
Thank you. I am thrilled that we have students like you and the ones that preceded you, and hopefully the ones that will come later, that are interested in Cuban infrastructure issues and solutions, even though they have no direct ties to the country. I really appreciate your efforts in that regard, and I'm very happy to see that we will engineer a better future thanks to your efforts. I think I noticed that your economic analysis is different than the one that was presented in the written paper. Could you comment on what the changes were and what were the major changes that you made between the written paper and the current one?
Yeah, the major changes is we consider about the retention time of the CAP pound and also HRAP pound. So previously we think that it take 1 day to process the wastewater treatment, but actually for CAP pound it could take 20 days. So the capacity of the treatment plant will decrease if we consider the retention time is 20 days. But currently we can still get a lot of benefit yearly.
Okay. I don't have the numbers directly in terms of what you assume were the revenues, but you had some significant numbers in the old one, which I don't see in here. The revenue from residents, you brought it down to 527,000. It was much higher than that before. Did you consider the ability of the Cuban people to pay? The numbers, I know the numbers you had assumed in here were rather high for the ability of the Cuban population to pay. I don't know what these numbers are based on now, but did you take that into consideration?
The benefit, it is about 5% of previously, because we, like I just said, that the retention time is right now 20 days, so it will scale down. And we calculate like the wastewater treatment revenue based on the population we will serve. The population is about 10,000 people, and I checked the price of the wastewater, and to calculate the wastewater revenue, it is a number here, about 0.5 million.
Okay. Last question from me. I don't want to take over this thing. You said that there were California and New Zealand systems that use similar systems to what you're proposing here, the microalgae systems. Are those considered commercially feasible, commercially available technology at this stage, or are they still in the experimental phase, et cetera?
So the one in rural California is at full operation for private use, or sorry, for public use, while the New Zealand one that we referenced a lot is in its experimental phase, but it has been proven to be very successful, and the New Zealand pilot plants are increasing in numbers and also spreading to Spain.
Again, I also want to congratulate you for the non-Cuban approach to the Cuban problems. Let me ask you a question. Where does the original algae to get this going come from?
So we talked to Dr. Ben Koopman when he has his whole doctorate was on microalgae, which was very convenient for us because he was in our department. But when we consulted with him, asking him where we could get this initial spores of microalgae, and he had said that during his experiments that the microalgae has spores in the environment already, that when we have an open source of water and nutrients, that it will appear at its most efficient state. So the species of microalgae is not controlled by us, but by the environment, because it will flourish at its most efficient. So if the most, let's say, desirable microalgae will flourish when we have the open pond set up. Mm-hmm.
I congratulate you because I see a very good feasibility study in this project. Do you think that your technology could be used in the excretion of swine farms?
Yes, the primary purpose of microalgae treatment plant started with piggery effluent. So this is where it originated in. So yes.
Thank you very much.
No problem.
Excellent presentation, excellent paper. And I thank you for being here. And double pleasure because it's two females presenting. I had a question. I'm kind of confused now after the presentation with a change on the feasibility and economics of the project. If the average and highest salary of a Cuban professional is compared to less than $35 a month, how much would it cost to a regular citizen of Cuba actually to pay for this service?
Yeah, it is a good question. We haven't looked into the workforce we need for this treatment plant. Our yearly revenue is about $0.6 million, and like you said, if we assume 30,000 for a job, then I think it still be feasible for this kind of treatment plant. Yeah, because this much is a lot.
Also, these numbers were based on U.S. wastewater treatment use and fees. So our avoided CH4 emissions as well as our methane production would counteract the reduction in revenue, I believe. Even if this was significantly reduced from the wastewater revenue from the citizens, the biomass production, the fertilizer production, and the methane production would counteract that as a buffer.
Thank you.
No problem.
Thank you, judges. Any questions from the audience at this time?
Thank you. Congratulations. I have two questions. One relating to operability of the plant. Do you think that the operational expertise exists or could exist in Cuba to operate a fairly sophisticated plant like this?
Yeah, actually, it is not complicated to operate this treatment plant. You see, so this one doesn't need really operation. The only process will be the process to extract the biogas, and it will need some people to take an eye on it, and it is very easy. And also for the HRAP, it is also easy. The only maintenance will be on this part, the pedal part, because we need the pedal to facilitate the wastewater flow. So it is also easy to operate it.
Okay, thank you. The second question has to do with land.
Mm-hmm.
If you were to put side by side two plants, this type of plant and then a more traditional, say, activated sludge plant,
Mm-hmm.
on a relative basis, how much land would each one of them take? Does this plant take twice as much land as a traditional, or 3 times? Or I'm concerned about the availability of land to implement this on a bigger scale.
Yeah, actually the CAP plant will not take a lot of land use. The problem is the HRAP, and it is true that the microalgae-based wastewater treatment will take more land use. And but we think that it is still feasible, and we referred to our advisor, Dr. Cookman, and we said that our treatment plant is about more than 10 acres, and he said it is fine for a treatment plant.
Okay,
Yeah.
thank you.
Thank you.
Thank you so much to the two presenters. Please give one big round of applause to them. Up next, we have our final, last and final team. They come all the way from New York, Maine, Boston, sorry for that. Suffolk University Team JCR. They will be presenting on improving the solar capabilities of Cuba From an energy perspective, the team members include Mr. Christopher Villar, Roman Diak, and Justin Bassett. Their faculty advisor is Dr. Stephen Jones, with industry advisors Manuel Cerejo and Juan Belt. So please welcome them onto the stage.
So good morning, everyone. Once again, to reintroduce ourselves, my name is Christopher. Behind me, I have Roman, and behind Roman is Justin, and we are all electrical engineering students at Suffolk University. And today we will be presenting to you our proposal called Keeping Cuba's Lights On with Solar Power. So to begin, we will want to give you guys a brief background on the current state of Cuba's electrical grid. Cuba's electrical grid is pretty old, and it's not very efficient. They tend to have a lot of transmission losses and a lot of blackouts on a very consistent basis. Between the mid-1950s to around, I believe, 1991, Cuba imported a lot of their oil from the Soviet Union in order to generate the power. After the fall of the Soviet Union, Cuba looked to Venezuela for their oil imports. As some of us may know, Venezuela is currently going through an economic and political crisis. So as a result, Cuba no longer can resort to Venezuela for oil imports. As a result, Cuba now has to look within their own nation for methods of generating clean and renewable energy. Also as well, I also want to add that a lot of the oil that they actually introduced from Venezuela, it's actually a high sulfate content oil, which isn't very good for a lot of the power systems that are used because they downgrade the systems over time. And as the population in Cuba increases, as well as the energy consumption, Cuba has to improve their energy sector in order to accommodate the additional load that we will see in the future. So behind me, you will see a chart now of Cuba's power consumption breakdown. These numbers are from 2014, give or take a few more percentages just because this is 4 years old. But we can see that almost 80% of Cuba's power generation alone comes from oil, and only around 5% actually come from renewable energy sources. Cuba has signed the Paris Agreement, so we do know that they do want to take an initiative and they want to contribute to renewable energy sources and promote it. They have stated that by the year of 2030, they want to be able to produce around 24% of their energy from renewable energy source. So we want to sort of give them a little insight of something that could be applied, and hopefully they take it into consideration in the future if they wanted to.
So providing the issue that there is a lack of efficiency and reliability within the electricity grid for Cuba, our team went ahead and decided to pursue the route of expanding on renewable energy and combining it with pre-existing wind turbine systems in certain remote locations that are accessible, that we carefully studied on the map of the Cuban island. So we're planning to establish solar fields roughly ranging in 10 to 15 megawatts of power outputage that would be combined with pre-established wind turbine systems that will be later explained by my colleagues in the presentation. We're also seeking to pursue an environmentally friendly resource of energy, considering the growth of tourism and being cautious about the wildlife. So installing solar farms would be an optimal and ideal solution to further expand the efficiency and sustainability of Cuba's power grid. Why solar energy in Cuba? Our group considers and strongly encourages the Cuban government to invest in solar and combining it with wind turbines because of the ideal location next to the equator and good irradiance numbers, where actually Okay. We're focusing on the province of Holguin and province, no, in the town of Gibara, which in 2004 their population was 72,000. So we're specifically working with that region. Considering and taking into account a limited and finite amount of funds as resources, as well as land area footprint, we decided to study various options of renewable energy and came to a conclusion that solar would be most optimal and efficient per area, as well as per dollar value per watt. One thing important to include is a system that is, any system that is installed will require maintenance and careful, restoration, or basically cleanliness. And we compared solar fields to wind turbines costs. So depending on the variety of a solar panel, a 1 megawatt system would roughly cost between $11,000 and $17,000 per year to maintain. Whereas a turbine system, we were looking at a 1.5 megawatt GE Chinese wind turbine with an output of 1.5 megawatts that takes roughly $87,460 per year to maintain and visit the site and have the wind turbine fully functional. So to get back to the optimal and ideal location, and the reason why we were promoting to use solar energy on the island of Cuba is due to the ideal location close to the equator. And here's a quick, here's a quick graph of the average kilowatt hour of energy from sunlight. So this graph is designed basically for a space of 1 square meter. So this is basically explaining if, assuming you have a 1 by 1 meter solar panel, and they're describing the average irradiances for 22 years. And this data is gathered by the NASA Atmospheric Data Center, and this is a 22-year average of the region we're actually claiming to work with. And you can see that the average per year is 5.6 kilowatt hours per meter square per day. So if we compare this with Germany, who recently set up a gigawatt factory, their irradiance rate per square meter is an average for the entire country of Germany is 2.9 kilowatt hours per meter square per day. Southern California averages between 4 to 5 kilowatt hours per meter square per day. So here we see good numbers at 5.6 kilowatt hours, and this is in the town of Gibara, close to off the shore of Velasquez Beach, basically.
So when determining the ideal location to install these solar panels, we looked for 4 unique features when determining the specific location. One, we wanted there to be pre-existing wind turbines. The whole idea of our proposal is to integrate wind turbines and solar panel in order to maximize land usage. In addition, we wanted the land to be cleared out. This minimizes costs. In the general construction of wind turbines, land has to be cut down for the transportation of the rotors. So this, by having clear land, it kind of would minimize the cost of also solar panels as well. In addition, we wanted this location to be accessible. We wanted to introduce this project with the idea of making this a very feasible application. We want it to be something that can actually be affordable. So we looked for roads that are already pre-built in order to minimize the cost again for a project like this. And in addition, we looked for a location that already had a substation in place. We can assume, since there are wind turbines, we can almost guarantee that there is a substation nearby that transmits that energy back into their electrical grid. And when determining our location, we finalized on a beach called Velasquez Beach that is 1 to 2 miles away from Gibara, Cuba. And as you can see in the picture, those blue circles that you see, those are the current 6 wind turbines that currently exist. To the left of the wind turbines, you will see a red square. That red square is our proposed area that we would want to set up these solar panels at. So this land will be approximately 762 meters by 305 meters. This should accommodate approximately 82,500 solar panels, and it would generate just roughly around 12 megawatts, give or take, at peak capacity. And it could potentially power on at least 3,400 homes. These numbers are pretty rough. These aren't exact. We weren't able to locate exact data for Cuba on items like this, so we had to compare it to other nations with similar solar irradiance levels in order to give a rough estimate of what this system could potentially output. And in these pictures, you can see of a current solar farm in Germany, which has a very similar, I guess, design to the one that we want to propose, a very linear setup where the solar panels are sort of set up in a parallel fashion. This also pretty much maximizes the land usage and allows us to pretty much install these solar panels in a very compact fashion. And they will be set up on metal railings as well. That would give some flex room. Since Cuba is a tropical island, we kind of know that there is going to be some strong winds every now and then, and they go through natural storms. So by giving these metal racks some flex room, it actually allows the system to be a little bit more stable, which we figured out from our research.
Another reason why we think that solar is a great supplemental renewable energy source is because the average wind speeds in Havana are not that great overall. 26.5% of the time, they don't produce enough energy for the wind turbines that they have to produce less than 13% of their max output. So a quarter of the time, they're barely producing little to no energy based on like the power curve of some of the wind turbines that they use in Cuba are a lot of Chinese technology. Those 6 that he was talking about are 6 750 kilowatt Goldwind wind turbines. So 13% of that is less than like 100 kilowatt hours. Havana specifically has very low wind speeds. Sorry. As you can see from the graph over there are a couple places where they have more wind, but for the average is pretty low. Compared to solar energy in Havana, wind turbines produce electricity almost 11% less often than solar would in that instance. Solar versus wind output, this is based off like a 60 per 60 acres. It produces almost 3 times as much energy in the same area. This is based off the fact that wind turbines need to be spaced out a certain amount. For static setups, they're usually all in like one line. They have to be spaced out about 7 times the length of the rotor. And for the 750 kilowatt Chinese wind turbines, that's about 50 meter rotors, so it's between 350 meters are supposed to be spaced in order to be the most efficient, have the least amount of wind turbulence. Again, the area usage, solar uses approximately 3.5 times less than a static wind turbine setup where they're all in a line, and 9 times less space than a multi-directional wind turbine setup where they're made to change the angle of the wind so they get the maximum efficiency from the wind. Cost of solar versus wind. We couldn't find a reliable source in Cuba for actual prices, so we based it off of US pricing for the actual product itself. Between 85 cents to $1 per watt is pretty typical for the cost of solar panels. And for a 1.5 megawatt GE wind turbine, that's a pretty common model. It's approximately $3.3 million, which is about $2.20 per watt compared to the 85 cents to $1 watt of solar. In conclusion, we think solar energy is a great renewable energy resource for Cuba. They already have some solar and wind, but if you can implement solar and wind in the same area with kind of like what he was saying, the area is already pre-cut, there's already a road, there's substations involved. It would reduce the cost to already just tie into the electrical infrastructure that's presently available. And it would also minimize land area usage. Cuba's not the biggest country in the world, so they don't have the most land. They can't afford to just, make massive solar farms like in Southern California and out west in the United States. And I think that's about it.
And before finishing off, we just want to thank our electrical engineering professor, Dr. Schatz from Suffolk University. She actually was the one who actually told us about this competition, and she convinced us and suggested us that we participate to get a real-life experience. We want to thank her for her feedback throughout the process of this project. As well, we want to thank the Association of Cuban-American Engineers, as well as the Cuban-American Association of Civil Engineers for taking the time to listen to all of our proposals today. So thank you very much.
Thank you so much. At this time, we'll open it up for questions from our judges. Who wants to start?
First, I want to say thank you, to all the other teams, and there's no conflict of interest, there's no relation between Chris and I, even though we have the same last name. One of the things that wasn't clear to me from either the written paper or the current presentation is, what are Cuba's renewable energy goals? You stated in there that they had a 20%, 20-some% by 2030. At an estimated cost of $3.5 billion is what I recall from the written presentation. But solar was only like 1/3 of the goal, if you will. What else are they relying on, and what are the costs associated with it? What are the alternatives, basically, to renewable energy?
So they have a couple things. They're doing a lot of wind right now, and they also have solar is a big thing. But combining the two was what we really wanted to emphasize. They also have sugarcane is a big product out of Cuba. So they have something called bugasi. I'm sure I'm probably butchering that. That's can also be used as a biofuel. So the sugarcane crop it's fluctuating in the past couple of years. It used to be really big. It hasn't been quite as big the last couple of years. They can use something called that combined with a cogeneration plant. So they have, they produce the sugarcane, the bugasi that's left over that can be used as a biofuel to, they burn that and they make steam and produce power out of that, which whatever's leftover energy from the sugarcane plant can be sent back out to the grid.
Thank you. This is a 12 megawatts plant that you're proposing at this point, and it is in an existing area that has infrastructure associated with it, et cetera. I am assuming that there's going to be a very limited number of opportunities for something like this, where you can co-locate an existing wind farm with transmission associated with it, et cetera, close to a population center. Based on that, I'm assuming that the rest of your proposal will be to look for these particular opportunities first, and then expand to other areas where the potential may be higher, but will require significant transmission in order to deliver the resource, et cetera.
Yeah, so definitely that's kind of our main point of our proposal is, since there are a few wind turbines already in place, there is a lot of available land around them. As Justin said earlier, Cuba has limited amount of space, so our proposal is more of maximizing the space that's there. If there is space available to install solar panels right by a wind turbine, for example, it maximizes the land area usage, and it produces the most amount of power, per acre, or however much space you have available to you. And moving forward, you can easily look for other locations to maybe implement both technologies from scratch. But at least for the case of this proposal specifically, we are looking for wind turbines that already exist, and just further enhancing them with additional technology to sort of pick up each other's slack, in a sense. When one isn't producing as much energy, the other one can probably produce some of that electricity that's being lost.
Another one of your points that you made was that Cuba basically has somewhere around 17% transmission and distribution losses. If you don't want to penalize every new source of generation, regardless of the source, whether it be renewable or new gas or whatever, with a 17% penalty, have you considered what could be done to improve the T&D system in Cuba? And I'm assuming that they're not including losses in the calculation, but if they do, that needs to be addressed also. I mean, I'm sorry, theft or non-payment of...
Yeah, so definitely. So one of the main causes of their transmission losses, it's improperly mounted, I believe it's conductor mounts. So maybe, I guess, renovating or upgrading those specific mounts that were improperly mounted will probably decrease the transmission loss that they currently experience.
Yeah, the insulation is what one of the main efficiencies. That and the old technology is the other main one.
Yeah, again, congratulations. Did you look at the solar farm that Florida Power and Light has here in Florida for any of your data, or?
We compared it mostly to the ones in like Southern California. There's a 579 megawatt in, I think it's Rosada, California. That was our main comparison for it. Was the kilowatt hours per square meter was almost 5, so it was close. So we just had we got most of our numbers for taking a ratio from how much output they get at 4.9 kilowatt hours per square meter, and converting that into like the 5.6 kilowatt hours per square meter that the Guevara area has.
Okay, and another question is, here obviously where you have a solar farm, you're tied to a grid that has a production capacity that can produce whatever electricity you need at night, and also you peak during the day. In Cuba, when you put a solar facility like this, how are you going to do the night? How are you going to handle the night loads?
That's part of the reason why we think it's a great idea to have it tied in directly with the wind. I mean, usually when it's sunny, it's not always the windiest. So when it's windy, like during a storm, you'd be getting a lot of power from the wind, and you wouldn't be getting much from the sun. But on a sunny day, I mean, there's 330 sunny days on average in Cuba. It's a lot of sun. So during the peak hours in the day, they should be covered. But like you said, at night, they could have capacitor banks or something to help cover that. But usually, it would probably just be the wind, and then back to the old oil power generation at night.
Thank you.
Congratulations for your work. And I would like to ask you one question. Why do you selected Jibara? Because you have wind devices over there?
So we selected Jibara just because, one, because there is wind, and just when we were trying to locate the wind turbines already in Cuba, a lot of our sources were sort of misdirecting us to where exactly these wind turbines were collected. So we were able to locate the Jibara one, so we kind of just stuck with it just because it was probably the most reliable information that we could find. But this could easily be implemented in different sections of Cuba where other wind turbines exist. We're not limiting it not only for this specific location, but just for the sole purpose of our proposal, we just focus on this one location.
I am not an electrical engineer, but I would like to ask you, how efficient is to storage the energy that is obtained from all three sources? I mean, could you storage, or you have to use it continuously, day and night, or not?
So you can have like battery packs and such on, and such as for the storage of the energy. For example, like Tesla, for example, I believe they produce sort of these battery, like industrial sized batteries that, could charge up and sort of save the energy and then be used, during off hours at night or something like that. So you could use batteries to sort of gather and collect that energy and use it for later use.
Generally, it's not cost efficient to do that. You just, whenever the energy is available, you use that to supplement what you have, and the main power plants, the oil would just kind of come offline or come to a low while the solar kicks in, and then, vice versa at night, the regular old power plants, the oil would come back online, and the solar just wouldn't produce much of anything. And hopefully the wind would supplement as well.
Great job. I hope that you make it back home safe and that the flood has not affected your families. Questions have been asked by previous judges that I had here in front of me. And I had already cleared the fact that Villar was not related to Dr. Villar, that he's Dominican Colombian descendant. And I love to see the diversity shown in our industry. and how it really applies to any infrastructure around the world, and this one specifically in Cuba. So I wish you all lots of luck, to all the teams, and congratulations.
Thank you.
Thank you, judges. One point that I do want to make specifically, and I think some of the judges have hinted at this, I think knowing that as a Cuban descendant, and I was here at this stage several years ago, working on these projects, there's very little information outside of Cuba that we have access to. I think Elizabeth mentioned on this because she worked specifically with the University of Havana, but there isn't much access to real life information for some of the engineering mechanisms that we're trying to explain. And in addition to that, we have students that are non-Cuban descent, have never stepped in Cuba in their life, not only presenting to experts in the engineering fields, but experts in Cuba. So I do want to thank you guys for that, because putting yourselves out in this position to be judged on the culture that is not part of the specifications here is very important, and I do thank all of you for that. At this time, I do want to open up the floor for questions from the audience to this last team before we break for lunch. Any questions? Okay, so we will go ahead and take a 1 hour break. We will reunite here at 1 o'clock. And at that time, we will have our award ceremony where we will award first, second, and third place to the teams presented here just now. So thank you again. One big round of applause for this last team.
I want to thank everybody for here in the Cuban Museum. And using as the Cuban Museum is the Cuban-American Museum of the Cuban Diaspora. But the exhibits are open. If you want to go, there is three galleries on the first floor, and then the one over here, and they have an exposition right now ongoing, so you're welcome to visit those.
And I want to thank everybody again for this magnificent day. At this time, I want to go ahead and thank everybody for being here, the students, the judges, the external committee members, and all of the committee members from the Cuban Infrastructure Scholarship Competition, which we meet once every month for the duration of the year, and we work very hard to bring in mentors, advisors, and faculty to be more involved in this competition altogether. One of the interesting things about the competition is that it's so relevant to some of the activities that we're doing here within Miami and across Florida altogether. So the collaborative efforts between different associations. So at this time, I do want to welcome Dr. Elena Solo Gabriel to tell us a little bit more about the Association of Cuban, Association for the Study of Cuban Economy.
First, I'd like to say thank you to Regina, to Roger, to the committee, to the judges, everyone here, students, for a wonderful meeting, for wonderful presentations. It's great to see this kind of activity going on. So thank you, Regina. Thank you so much. I'm the president of the Association for the Study of the Cuban Economy. The association has been in existence since 1990. It came into existence during the special period in Cuba with the hopes that by coming together, there could be some advisory role, some influence on where Cuba's future was heading, because at that time, there was a belief that things may change because of the Russian withdrawal from, economic withdrawal from Cuba. And so this organization is a nonprofit, non-political association. They've been in existence for 28 years. One aspect that attracts me to this particular organization is that they're very scholarly. A lot of academicians, a lot of government people nonprofits. Every year they host a conference, and lately it's been in Miami. And over the course of 28 years, they've developed proceedings, 28 years worth of conference proceedings on Cuba's economic issues. They've published over 1,000 papers. I welcome you to go to www.asciicuba.org to take a look at some of the papers that they have published. The organization tends to interpret economics very broadly. They incorporate all aspects of the economy, including engineering is considered to be part of the economy. In order for an economy to thrive, you have to have infrastructure in order to support it. And so I welcome everyone here to come to the conference. If you'd like to speak at the conference, there's some of us in the audience have spoken. Armando Perez, for example, has spoken at the conference. We more than welcome Jose as well. We more than welcome participation. If there's an interest in putting a session together on infrastructure, on engineering aspects, we more than welcome it. We'd be very happy to host a session on those aspects. So I invite everyone here and friends and people that you may know, colleagues, to contribute intellectually to the conference. It would be wonderful. I also wanted to introduce Silvia Pedraza, who's in the audience. She is running for president. Very likely will be our future president of the Association for the Study of the Cuban Economy. She's also very interested. She's here because she's interested in the engineering groups, and we, again, very much welcome engineering within this particular conference. To help encourage this, and again, our conference is scheduled for July 26th through the 28th. It's going to be in Miami at the Miami Downtown Hilton. And again, more details are available at www.asciicuba.org. We also have Blanca in the audience who has helped us with advertising and marketing the conference to the journalists. Oops. Wrong direction. So at this point, I want to mention that as part of the conference, we do have a student paper competition. There are prizes associated with the student paper competition. We have two categories, a graduate and an undergraduate category. We more than welcome the students who are presenting today to also present papers at this particular competition. The due date for the papers is end of May. You may be able to refurbish, recycle your work, and also have another opportunity to present again, potentially in Miami. So at this point, I want to thank you again for this opportunity to present.
Thank you, Elena. Like Dr. Solo mentioned, we have this very strong collaborative society within this Miami area, and certainly outside into North Florida, that is very much involved and integral to the Cuban infrastructure, Cuban engineering within our two associations, the civil and engineering. We put together this gala, which is really to celebrate engineering within the Cuban culture, and we have that here over the next, in two Saturdays from today, March 17th, and that is going to be at the Miami Hilton. So anybody that is interested in joining us, those of you watching from the web, more than excited to see everybody come together for a fun night of music and food and awards too, for up-and-coming engineers within professional and college departments as well. So if you have any questions, don't hesitate to reach out to myself or find us at the web page here listed in this advertisement. With that said, I do want to move on. For everybody's excited for the competition this year and the awards. I do want to welcome Roger and Jose Enrique up to the stage, representing the both organizations before we give the awards. Prior to that, I do want to go ahead. You can come up. Want to give a special thanks to all the judges, and typically every year we try to do something nice for the judges because they've spent so much time and effort reading the long papers that have been submitted. So I do want to give you guys a special thank you and have each one of you come up and pick up your special plaques. So can we start with Vladimir Cruz? Next, we want to bring up Mr. Rafael Palacios. Up next, Ms. Maria Fernanda Porrada. Ms. Maria is the first time we have a women judge, so that is very exciting for all of us women engineers. And last but not least, Mr. Mario Vada. Okay, so now we will move on to the student competitions. And before I give the awards out, I do want to give some details on how these reports were scored. So from the written paper, we were looking for very clear statements and objectives. So the written report accounted for 40% of the total grade, really looking at originality, creativity. A strong component of economic analysis was taken into consideration for every report. And then with the oral presentation being 60% of the part of the total scores, we were looking for organization within delivery, coverage within the time limit, and looking for creativity within the presentation as well. So without further ado, I do want to give out the third place. We will start with the third place. And the third place award goes to the University of Alabama. Miss Elizabeth, Preston, and can we have Eric come up and receive the award with them too? Moving on to second place, and from second place, I guess you can determine who the first place winner is. So big drum roll for the second place team is the Suffolk University team. Mr. Christopher Villad, Raman Dayak, and Justin Bassett, with industry mentors Manuel Cerejo and Dr. Juan Belt. And now, last but not least, and by default, we have the University of Florida taking first place. So Juan and Mayu, congratulations on your first place award. Now to close off the ceremony, Mr. Puerto and Jose Enrique, representing the association, or the Civil Engineering Association, will give some words.
Hi, as Regina said, my name is Jose Cueto. I'm the Vice President of the Cuban-American Association of Civil Engineers, and I just want to say how inspiring it's been to be here today. Starting off with Professor Julio Cesar's description and kind of historical perspective on where we've been in Cuba and the great things that have happened through architecture and through engineering over the years. The presentations today and the groups have been fantastic, have been fabulous. So congratulations to each of you for great work put forth and amazing projects. It is inspiring to see folks, people of Cuban and non-Cuban descent take on Cuba's infrastructure problems as their own. So congratulations to each of the groups today. I just want to applaud you for that. We at the Cuban-American Association of Civil Engineers welcome each one of you, civil engineers in particular, to come join us, join our group. We are an inclusive group of Cuban and non-Cuban civil engineers. As Regina mentioned, we have our gala coming up in about a month's time. So if you could spread the words within your universities and with your schools, we'd greatly appreciate it as we continue to grow and evolve over the years. I think this is our 57th annual gala. So it's an organization and organizations that have been around for many, many years. While I'm here, I'd just like to recognize some of the folks from our board, from the Cuban-American Association of Civil Engineers who are here. Ms. Maria Porrata, Mr. Victor Puyal, and some of the folks who have left, Rafael Roaina still here, Cristina Ortega. So thank you to all. Congratulations to the participants. Thank you to the judges, and thank you on behalf of the Cuban-American Association of Civil Engineers.
Well, without a doubt, everyone was a winner today. I mean, not only because we had three groups, everybody got money, prize money, but from the point of view that the presentations were excellent, and I know that I spoke to the judges and they had a hard time. There were some folks that really came up on the oral presentation, the oral presentation 60%. And I really, I was very, very impressed with the way that every one of them presented, every one of you presented, every one of you defended. So again, that's a credit to you, and don't forget to add this to your resume. I mean, that to me is it's one of the reasons why you do this, and it's because of the fact that it helps your resume, and it should help. And again, I wanted one person that I did not recognize at the beginning of the day was Blanca Silva. She's on the back. Yeah, well, you know, and the reason why every group needs publicity, and she has been able to get the word out. As a matter of fact, a couple of days ago, Miami Herald published the letter, less than 200 words, I believe, that we provided to the Miami Herald, and we had a radio interview this past week that Maria Porrata and myself was involved, and as much as we can get the word out as to what each of you do every single year, and what you have to do to prepare to do this as a side event. I think it's important for people to know that we really care also about the future of Cuba should the Cuban people have a government that allows them to be free. And that is very, very important as we look at the future. Again, representing the Association of Cuban-American Engineers, and as good Cubans, we have to have, what was that? Well, I'll pick it up later. As good Cubans, we have to have two associations. So with everything that we do, we cannot just have one, but we have two. And that's typical of us, by the way. And but representing the Association of Cuban-American Engineers, I want to thank everyone involved. And everyone involved, this is not okay, we come in one day and it gets done. I mean, we begin the process in actually April of the following year. So our next meeting will be the second Monday in April, 5:30 in the evening, conference call, meeting in person, and that we begin the process for next year. And definitely one of the things that we would like for each of you to do is come back next year, okay? Number one. Number two, tell your friends that this is really a good thing. And, we have University of Michigan represented here, so the University of Michigan almost presented. At the end, they said that they didn't have time, that they were going to do it next year. It's very, very concerning that we don't have a team from FIU and that we don't have a team from the University of Miami. I mean, those are two local universities that we can attract more people here. So we got to do whatever we can next year to actually have more teams presenting. I mean, last year we had 15 teams that submitted papers. We had to do a midterm judging and then the finalists. So again, this year we had a couple of reasons, the hurricanes and so on and so forth. And that's why I want to thank you from the bottom of my heart that you guys actually spent the time and did what you did to come here today. But I also would like to recognize if I leave anybody from the board out, the Association of Cuban-American Engineers from the board out, let me know. We have Regina, who is the president-elect. We have Bert Silvestre sitting there. We have, let me see, Helena, Dr. Helena Soto Gabriel, Associate Dean of the University of Miami. So I don't know if anybody told you that, but she also has a PhD from MIT in water treatment, environment, so on and so forth. Past president, a person that has really helped us a lot. So I don't know if I left anyone. Sergio Clary also has helped tremendously. He's picked up a lot because, we need to begin to pass the mantle to other folks that are involved. And more than anything else, I also want to thank Regina's mother, Odalki Hernandez, that's here today. And she's been helping a lot, and thank you very much. And I want to thank all the people that are involved in the committee. Victor Pujals. Victor, by the way, was the person that actually brought Julio Cesar Perez Hernandez here. And I thought that he did a fantastic job, as Jose Enrique said, in doing the presentation. I'd like to thank Dr. Miguel Medina. Thank you. Emeritus professor from Duke University. We have some high caliber people involved here, okay? Dr. Armando Perez. You basically met him as Armando. He's Dr. Armando Perez, okay? He was very, very much involved in industry, involvement with, as a water treatment specialist. So let's see if when you start naming people, obviously Bert Silvestre, retired from ABM, was still very much involved in the IT world. And did I leave anybody out? Did I leave anybody out? No? That's it? Good. Thank you. Thank you for coming over. I hope that you have a good time tonight. Go by Buya. Have dinner at Buya. And tell them that you know Victor. Okay? Thank you very much.
I did want to close off by thanking Wen Cruz for the filming and the live streaming of this event. The American Museum that's hosting us today and this really nice stage. And then also Buya Cafe. They are our main sponsor, so we're very grateful for all that they've done for us. And definitely if you are staying for the next day or two in Miami, visit them at Doral. Or even here at Coral Gables. Their food is really magnificent. So with that said, thank you so much for your attendance today, and for those viewing us live within YouTube and Facebook, thank you so much for watching, and we will see you next year for the 2019. Thank you to Ileana Fuentes. And to Ileana Fuentes and Carissa from the American Museum here of Cuban Diaspora. So thank you again, and have a great Saturday. Thank you.